All right. Hi, everyone. So we have back-to-back streams today. And if you have joined some of the developer Q&As that we've had in the past, there's been a lot of questions about Pinocchio. And now we have the privilege to be joined with the creator of Pinocchio, Febo. And he's going to talk about Pinocchio and give us a little introduction. So Febo, you want to introduce yourself?
Hello, I'm Febo. Sometimes people call me Fernando as well. And I work at ANSA in the platform group or team.
Awesome. And for anyone that doesn't know, Anza is a group of engineers that work on building like the core protocol of Solana and a bunch of different tooling that also works for developers. So we're going to go through a little demo of Pinocchio and just chat about why Pinocchio was created. Do you want to first just give some background on what inspired Pinocchio?
So if people remember, kind of like just over a year ago, um, like Solana program was the crate that you use to create programs. And but it's kind of like at the time was a heavy crate, lots of dependencies, lots of external dependencies. So it was very, very easy to end up in kind of like a dependency issues because that crate at the time had kind of like two purposes. It was bringing the Solana SDK that was kind of like built more towards off-chain clients or off-chain utilities, and also had types and other things that you needed for programs. But there was kind of like combined. And so you're bringing all these bunch of dependencies and you're not really using them in a program. So that was the main drive to kind of like come up with something a little bit better. So we were chatting with John. This was like London Hacker House, was June last year. And then in that conversation came up the idea, what if we just build an SDK that has zero dependencies? Because then you don't have dependency problems. And that's how the Pinocchio idea started. And since we were there already, kind of like having to kind of shred dependencies and avoiding external dependencies that were not needed, then we took the time as well to kind of like rethink the types, how to make them more efficient. And that's how then eventually like Pinocchio kind of has this all like kind of like a big performance increase compared to the kind of like Solana program crate, because we kind of like rebuild these types with kind of like in mind like CU usage, and then we managed to reduce that as much as we can. At the same time, we got some amazing contribution throughout all this process. So whatever we have today is kind of like is a collective effort, and yeah, that's basically it.
Awesome. We have someone in the chat just saying thank you for creating it. So it's a little shout out there. So do you want to dive into the demo that you prepared? I will share your screen.
Yeah, so the idea here is kind of casual. It's not completely scripted. And we go along and see what other things we can show off. But there is one main thing that I wanted to start with, is that showing like how you can measure the performance of the entry point of your program. So the entry point of the program is kind of like is where your program starts. And that you don't have much control of what goes there because you don't really touch that part. And once you get to your program, the entry point already kind of like parsed the input and gave you all those types nicely. So for people familiar with native programs, this is how an entry point is going to look like. You're going to use this macro provided by the SDK. That is, you're going to then say what is the instruction that is going to be called after the entry point parses the input. And in this case,
I'm just going to stop you for 1 second before we get deep into the code. For anyone watching, I know I don't have the chat shown on the screen, but I have it open. So if anyone has questions, make sure you ask them in the chat. and I will ask them to Febo as he's coding. Yeah, definitely take advantage while we have Febo's time if you have any questions. So throw them in the chat. But go ahead, continue.
All right. So this is at the moment, this is process instruction here is empty. I only put this directive here to tell the compiler, leave that there untouched, because otherwise the compiler might just take away this my function, and then what I'm trying to measure is not going to measure. So basically, the purpose of the entry point is to parse the input, because the input of the program essentially is literally a byte blob, which has pieces of information that your program needs. It has the accounts that your program is gonna manipulate, has the instruction data, so your program knows what are the kind of like inputs that your program are getting, and is also have kind of like the program ID of your program. So the entry point is gonna go there, chop that input, and give you a nicely breakdown structs here. So we get pub key, which is the program ID, a list of accounts, and we have the instruction data as well. So the first thing that I'm going to do here is I'm going to just build this. I think it's built already, but just to make sure, yeah, it's all built. And I'm going to then run a simple benchmark here that I created that is going to call this program with multiple number of accounts for us to actually measure what is the performance of this empty program in terms of like in relation to the number of accounts that I sent. So this is going to then send several instructions to the program. And if we open here my result, we can see here the performance of this, where when my program gets called with one account, it uses 261 CUs, with two accounts 404, and so on, and gets to 64 accounts 9,270. So this is CU consumption that it got even before your program did anything, because you saw that our program essentially is empty, doesn't do anything. So this is something. So this consumption is all to do with the entry point.
So
the first
question, for anyone that's watching that is new to Solana, one of the key things to look for when you're building smart contracts is just optimizing for compute units. And you just want to give a quick overview on like why that's important and like why you're using this, well, why you're demoing the compute unit optimization.
So the compute unit kind of like is going to reflect how expensive, in a way, is to execute a transaction with a program. Because the more compute units your program consume, likely you're going to have to send more priority fees so your transaction lands, because it's kind of a heavier transaction, because each block, the block has a finite number of compute units available. And if your program uses less, that the chances that you kind of like your transaction is included in a block increases, because you just use a tiny little bit. So you're going to be included. Now, if your program uses a lot, then chances are that, well, this is you're going to need a big chunk of the block space to execute your transaction. So chances are that you're going to have to pay a little bit more in priority fees, so then you can be sure that your transaction is going to be included in the block. So reducing your compute units means that increases the chance of inclusion of your transaction in a block without you having to increase the fees that you pay. So essentially, and compute units, in a way, is just the number of instructions that your program is going to execute. So the less instruction that your program executes, the less compute units your program is gonna need. So essentially, is literally a one-to-one relationship. Compute units is kind of like each instruction, each is kind of like statement that your program is gonna do, but not statement in kind of like Rust sense. It's a statement on the byte code that the Rust gets compiled to. So when you look at the Rust code, it's difficult to say, okay, this is one statement, but that one statement can translate to 100 instructions at the bytecode level, and that's going to be like 100 CUs.
Okay.
So there's the importance. There's the importance of, like, if you have a lightweight program, you not only make your life easier to send transactions, but anybody else using your program is also going to be happy because it's going to be a lightweight program to call.
Awesome. Thank you.
So I think as a first kind of like step towards, okay, let's see how we can do this with Pinocchio, and then we see what is the actual impact that that would have. So I'm just going to create here a new program. I'm going to start by just copying what I have here over. So I haven't changed anything yet. So just copy it over. And I'm going to do the necessary modifications now. I'm going to call this Pinocchio. When you're doing Pinocchio, you don't need this. You don't get warnings for these configurations because we don't use them. And the dependencies now get reduced to just using Pinocchio. And the latest version is 0.9. So in terms of our crate configuration, this is what we need. And when we go to our code, we just literally just need to change the imports in this case. So we're not using Solana pub key anymore. Let me just put this on the workspace so we can actually get some help from the compiler to tell us what's wrong. And then we can just fix what's wrong. So I'm gonna just wait, flags up with the errors, and then we can just fix the.
Awesome. So while that's loading, a few questions that came in. One is, it's a different structure from Anchor. Do we have to learn the native Rust before moving on with Pinocchio, or can we just directly start learning Pinocchio without knowing native Rust development?
So first of all, the first question is different than Anchor, because Anchor, if you think about Anchor, Anchor is a higher level library, kind of like a framework. So Pinocchio is more kind of like this foundation library, and which enables frameworks like Anchor to be built on top. So right now, the current Anchor version is built on top of the SDK, the Solana SDK. But the future version then is going to start using Pinocchio underneath. So Pinocchio is kind of like a lower level than Anchor. So it doesn't really compare to Anchor directly. If you're familiar with Anchor, you can start learning a little bit more about native Rust, and then eventually you would stop using Anchor and you could start writing native Rust instead. So it's kind of like different levels in the stack. In terms of native Rust and Pinocchio, native Rust in the sense of the SDK, I would say either way is fine because they are so similar. And I hope that in this video we can actually you can agree with me that it's so similar that whichever one you learn first, you can switch between them each other because essentially follows literally kind of like similar principles. The data types are similar. What mainly changes is the imports, and we can actually see here. So obviously this program now doesn't have Solana pub key anymore, so I'm just gonna get this one. And because it has the Pinocchio dependencies already telling me, oh, there's a pub key here in Pinocchio, so we're gonna use that one. The pub key in Pinocchio currently is just an alias to an array. So I can just do this, and I have my pub key now, my program ID pub key done. To know the compiler that didn't like the version of the great. Let's see now. Just refresh the compilation. So that should be good. I'm still waiting just to get the errors now on the entry point. So this one should be done. So this was the only change that we did. It was changing the type to use the Pinocchio type. And because the pub key in Pinocchio is just an alias of bytes or byte array, we just switched that. So that's okay. So that we fixed already. So here we're going to do the same thing. I'm just going to get rid of this completely. And then expect the compiler to tell me that something are wrong. So I'm going to, the entry point is also an entry point. I get the pub key, I get the count info, and I get the program result. And that's it. We converted our little program to Pinocchio now. So I'm going to just make a modification here on my build script so we can actually build this program as well. So this is the Pinocchio one. This is totally optional. This is just so I can just type build and I build it both in one go. I'm going to rerun that first bench that we did, which the SDK, because I had to clean I cleaned the build, so it deleted my results. Because I'm using underneath a tool called Mollusk, which is also developed by Anza. And it has this kind of facility to create benches. And when you run a bench, it actually displays or writes a file with the CU usage, which is what we see here. And then if you run again, and you get different results, that is going to show you the difference. So I'm going to run them again, but now I'm going to run in the Pinocchio version. No bench target. Oh, yes. Saying that, now we need to do the same thing on our benches. So on our benches here, we need to create the version for Pinocchio. So I'm going to create the Pinocchio here, and let me just close this for a second. Should be all right. The only difference here is change for Pinocchio. Okay. All right, everything else should be fine. You see here that on the client, on this client, we are still using the Solana types because the Pinocchio is a library for on-chain programs. So when you're writing a client, the client still uses the SDK. So that doesn't change when you use Pinocchio. Pinocchio only changes how you write your program. So now we created our bench. Pinocchio is there. Probably this has to be called Pinocchio. So, yeah. And if we go back to our results, let me just close all of this. You see here the difference. Let me just make this a little bit bigger. Okay. So here you see the difference that, for instance, for one account, the SDK takes 261 CUs, Pinocchio takes 17. 2 accounts, Pinocchio still takes 17 as well, and the SDK takes 404. And then the extreme case where you have 64 accounts, Pinocchio takes 504, and the SDK takes 9,270. So there you're saving kind of like 8,700 and something CUs. This is just on the entry point. So this is something that usually you don't have control over it unless you rewrite the entry point yourself. So it's something that just by switching that, which literally was just switching some imports, that's kind of like the performance eventually that you're gonna get.
So this is just passing accounts through up to 64 accounts in a no-op program, and it's the
exactly.
Okay.
Yeah.
Exactly. And then you can have a delta of over 8,000 CUs if you're passing 64 accounts through.
Yeah, it's almost 9,000 to be fair. It's like
Yeah, that's crazy.
8,766. Yeah. And this is the reason why like how this kind of like improves so much. The reason is that the SDK, what it does is kind of like allocates some VEC, and it copies some data from that input buffer, which is kind of like this byte array. It copies some pointers, some values from that, and puts in this VEC of accounts. And Pinocchio doesn't do that. Pinocchio, what it does is said, okay, you have this byte array. This is the section that is an account. So treat this as this account instead. So it doesn't do any copy there. So this is what essentially zero copy does. So zero copy avoids, when you have a byte array, avoids copying data from this byte array into a type, which is expensive, and instead looks at the bytes and say, okay, now I'm gonna pretend that those bytes are this type directly instead of copying them. So this is all like zero copy in a very high level description. The way that it works is kind of like the name of that is zero copies because you're not copying the data to reinterpret the bytes into something else. You are looking at those bytes and say, okay, I'm going to pretend that that's the type that I want. And the pretend is safe as long as is the type that you want. So as long as you check that that is the type that you are pretending it to be, then it's safe. There is no problem in doing that, and it's much cheaper. So once you're there here on the kind of like once you're there in your program. So here I'm on the Pinocchio program. So let's say I'm gonna get accounts 0, and then I'm gonna have all the things that you expect an account info has the borrow, has the assign, the try borrows, is a signer, is writable, is all those things, kind of like all the things that you are familiar with. So try borrow data, and then you get the data of the account and so on. So all the familiar things that you have on the SDK are there. So if we get this, let me just see if we do this. So if you do that, so that compiles, no errors. I'm gonna literally copy that here. And it also compiles with no errors. So it's kind of like, as I said, the API is very similar. So once you kind of like change the imports, the rest is going to be super familiar to work with. But on top of it, you are actually saving kind of like a lot of CUs.
So we have one question just following up from your explanation. So there's a lot of CU consumed by all of the unnecessary copies. And then the follow-up question was, why do other frameworks do that?
So yeah, the first question is yes, there is lots of copies that are unnecessary. That is, well, yes, you could say unnecessary. It's like you could say it's a different approach to do it. You can do it like that way, or you can work with kind of like a zero copy style and kind of like save those CUs. The tricky, there is like zero copy doesn't come for free. It's not something that you say, okay, well, just why don't you just use zero copy? Zero copy is a little bit more tricky to work with because when you're doing zero copy, you are working with references. And when you are working with references in Rust, then you have to start thinking about lifetimes. And so it's kind of very easy to end up with like lifetime issues, borrow checker issues, and things like that. I mean, like issues in the sense that you get, oh, why is this not working, kind of thing. Like the compiler is telling you that the lifetime doesn't live long enough, and you're like, what is this about? So there is that kind of like, it's not for free. that kind of the performance gain there, you have to understand a little bit more about what you're doing. And then depending on what you're doing, you're going to have to find a different way to do it. When you copy data, there is no problem. There is no lifetimes. There is no borrow check and nothing, because you're just copying the data. So it's easier to copy the data than to pass references. So there are different approaches. When you're working on kind of like, if you're just writing a CLI to do something that you like, I don't know, like a price tracker for like a specific coin or something, you're writing a CLI, might not make a big difference, or probably doesn't make a big difference if you're using zero copy or if you're copying the data. At that level, probably doesn't matter. But then when you're writing a program, then it's different. Then is it because the program, you know that kind of like every time you allocate memory is gonna use CUs. Every time that you copy data is gonna use CUs. And you say, well, I don't need to allocate more memory. I don't need to copy this data. I can just do zero copy. And then all of a sudden you save a lot of CUs. So the CUs that you see here, the gains here, are mainly to do with avoiding copying, allocating memory and copying data. That's the main thing. The other example that we could quickly go over here is, let's do this. Let's do one to show again where there is more copies that you can avoid, and that kind of like Pinocchio helps you to avoid. So let's keep in mind. So I'm going to do a let's do a create account. So create account on the system program takes 3 accounts: the funding account, the account that you are creating, and the system program account itself. So the difference that we have between the SDK and Pinocchio is 510 CUs. So if the invoking the system program, doing a CPI into the system program to create this account were the same, we would see only 510 CUs difference. So let's actually see how much is going to be different. So so for that, I'm going to need what am I going to do? I'm going to need the CPI, because now I'm doing a cross-program invocation. I'm going to need the I think the system interface and the latest version. The latest version is, I think, is 0.2. No, sorry, it's 0.0. And we need to enable the feature. So we have the instruction builders, so pin code. Okay, so that is going to give you the types that we need. So here we're going to get, so I'm just going to destructure here my accounts. I'm not going to do validation here. And so, actually, well, we can do the validation. Let's do the validation. So the first account is the 2. The second account is the no, I'm not doing that. So getting the first account is the from, so it's the funding. The 2 is the one that I'm creating. The 3rd is the one that I'm inspecting. And then I'm going to get, but if I don't get the correct number of accounts, I'm going to return an error, which is going to be a program error, not enough account keys. Yeah. We need to add this type. Yeah. Okay, so we have a little bit of validation. If I don't get those 3 accounts that I'm inspecting, I fail. Then I'm gonna create my. Can I just turn this off? Okay, let's snooze this because you're on my way. Okay, so we do create account. That's it. That's the one that I want. So I have the from key is the one that I'm sending. The to.key is the one that I'm creating. LAMP ports, I'm going to arbitrarily put 1. I know that my tests, I think, is sending 2 sol on each. So I'm going to put 1 sol to that. The space, I'm going to put arbitrarily 10. Like this is completely arbitrary. And the owner is going to be my program. Which, if I wanted, I could actually use this file here instead. Okay, so I have that. That's my crate. Now I need to create my. I need to create an array with my account infos that I need for my program, and we don't need to send the program account because that's the program that I'm invoking. So I just need to send the 2 accounts, the one that is funding and the one that I'm creating. And I'm going to comment this out for now. And I'm just going to do the invoke here. And I'm going to say, okay, my instruction is this one. And my account are here. Okay, so this should be good. Yeah. Okay, yeah, I'm not going to use this. So, okay, so that's good. We're going to view that, see if that's okay. That's okay. And then I have already a bench prepared for that, which is the CPI. And if we go here, the SDK. Okay, so this is it. So I did, okay, the name is wrong. Shouldn't be transfer, it's create. Or maybe we did the transfer before, but let's go here and just make it look properly. So
Also, while you're updating this, you're creating the bench test with Mollusk, right?
yes.
Yep. So anyone curious what Mollusk is, we actually have a video with Joe, who works on the same team as Febo and created Mollusk, and we'll have that live hopefully soon. And we'll be going into how to use Mollusk. Mollusk is just like another testing framework specifically optimized for unit testing. Just some background there for anyone that's curious where these bench tests are coming from.
Yeah, exactly. I have them all here. I can quickly show you like what I have there is that I have these like, so essentially just these benches just create what I need. So if I'm running the bench run accounts, is you see here all the instructions that I'm creating and I'm benching them. The CPI is the same thing, and just preparing the accounts for the CPI and then executing the instruction. But then eventually gets called, my program then gets called, and then Mollusk records the compute units at the end. And this is what then eventually gets in this table. So this SDK, a create account takes 2,446. CPIs are expensive by default because it's like 1,000 just to do the CPI. But let's see. So here it was not that complicated. I'm actually going to copy this here, and I'm going to go. This is going to be different on Pinocchio because Pinocchio is going to use lightweight types. So what is happening here is that you have to create this instruction. This instruction, the instruction type inside is going to have a vec with your accounts. Can I show you the vec? Yeah, so here it has a vec with instruction data. And then when you create the invoke, some stuff gets cloned, and then you're cloning a vec, and so that's where that CU's kind of comes from. So let's see like how that looks like in Pinocchio. So that part here is the same. The program error also exists in Pinocchio, so it's the same. But now here is different. Here is different because we're not going to use the kind of like the invoke the same as the SDK. We're going to use what Pinocchio offers. And in this case, Pinocchio offers a kind of like a CPI helper for the system program, similar to what we were using on the SDK, but it does already the invoke for you as well. So this one is, I think it's version 0.3. And then what we get is that we get this create account. Yeah, this one. So you see here, system program create account. And it works a little bit different in the sense that we have the from. You pass already a account info. So you don't have to pass the keys first and then pass the account info later. The LAN ports we're going to pass the same. And I think the other ones we're going to do the same. Oh, space, I don't know. I think we did 10 with the other one. This not one is this more. Okay, lose it forever. Okay, so we set 10, yeah, and then here is owner, and let's use our program ID. The program ID, and the thing is that once you create this, you can actually just do invoke directly here. So it's kind of like underneath is more or less doing the same thing because it's kind of you're passing the accounts that you need, the LAN ports, space, and the owner. Just a little bit different that it kind of like packs in a way that you just then can call invoke directly. So I'm going to build this again. And then I'm going to run the same bench, but now I'm going to use Pinocchio. And we're going to have a look at the results. And we see here that Pinocchio was kind of like 1,165 CUs cheaper. So remember that 510 was something like that, 500 and something was just the entry point when parsing 3 accounts. So that 1,100 is not only the CPI. That's 500. So let's say 510 is the accounts that you are saving on the entry point. So you're talking about 600 and kind of like 55 CUs for the CPI. So the CPI functionality to create an account in Pinocchio is about 665 CUs cheaper. And why is it cheaper? If we look at the invoke, what is it doing? Is using everything is sort of kind of like a reference. It doesn't really kind of like locate a vec. So if you look at the instruction, how the instruction looks like in Pinocchio, the instruction type is a reference to a program ID, is a reference to the instruction data, is a reference to an array of account methods, and so on. So it's everything is a reference. That means there is less allocation, there is less copies. And that's where that difference comes, the difference that we saw in terms of compute, because you are saving those copies that technically you don't need them. And it's still, in a way, kind of like providing a easy to use API. So it's kind of like you don't have to worry about like the lifetimes and so on. As long as you're passing the correct values here, then you don't have to worry about that part. So that's the sort of kind of like optimization. So when we said that, when we started with Pinocchio, and because we were starting reducing dependencies, we were looking at, okay, we can't use the pub key from the SDK because that is going to used to bring lots of dependencies. We said, okay, well, let's define a pub key type that we can work with. We couldn't use the instruction from the SDK because again, brings lots of dependencies. Let's define an instruction for Pinocchio. And when we're defining those is where we said, okay, but let's define them in a way that they are lightweight. If we don't need a vec, we don't use a vec because that's going to save us clones and so on. And that's where kind of like all the other pieces of Pinocchio follow kind of like the same principle, where you always have kind of like a lightweight type to work with. There are parts that if there is no other way, there's no other way, and then you need a VEC, you need a VEC. Especially because you like not everything can be on the stack of the program. Some things, depending on what you want to load, you need more memory. Then you're gonna need kind of like to allocate a VEC, but that's kind of like the last resort. If you have the option of not using that, then there is going to be an option not to use that. So again, doesn't seem a lot different. Hopefully, people agree. And all the things that we also then went further is a simple one that sometimes you don't think about, but I don't know, but people must have noticed that logging is kind of like expensive. Logging, especially logging formatted messages, is expensive. Logging by itself is expensive because it's 100 CUs just to do the syscall. But if you kind of like format something, then it gets even worse. So we could have a look at that one.
One question before we go on to the next topic. We did have a few questions just about what is the difference between native and Pinocchio, and I think this is a really good example. Do you think you could just split screen these two programs that you just wrote between Pinocchio and the SDK?
Yeah.
So you can see, like just.
Oh, wait, sorry.
Yeah.
I think I opened the same one.
Yeah.
No, yeah, cool.
There we go.
Now we have them. We can try to, let me just hide this. Cool.
Perfect. So here's just a great example of, a Pinocchio program and a Solana SDK program and what the difference would look like. So it wouldn't be that much of a change when you're switching between writing native programs over to Pinocchio.
Yeah, and just to say that this part here, in a way, kind of like you could write the Pinocchio one exactly like this as well. Like, as long as you created the same helpers with the Pinocchio types, this part of the code could have been exactly the same as well. It's just that that's kind of like, you could do in a way like this. Maybe that's completely kind of like subjective. Maybe this is nicer to use than having this. Some people might prefer a function instead of a struct. But then again, someone just can come up with a different helper that looks exactly like the one in the SDK, and you do the same thing. So this part is, in a way, is kind of like completely is tailored to your taste in a way. If you look at this other part here, is kind of like is the structure that you have to follow, and they are exactly the same. And as I show you in terms of like if you want to borrow the account data and so on, is going to be the same. That API is very similar. So it shouldn't be a lot different at all. And for people that mentioned to me when they switched from native to using Pinocchio, they said it was kind of like relatively straightforward. They didn't kind of like, it was not a major task to do it. If you're converting an anchor to native or anchor to Pinocchio, then the task is a little bit bigger. But then it's not just particular to Pinocchio, because anchor to SDK is a bigger task.
Yeah, and hopefully with Anchor v2, since it's going to be using Pinocchio under the hood, you can just convert from v1 over to v2. So it'll be a lot easier with DevX. Cool. Okay.
Cool.
Now you can go back to logging.
Yeah,
Sorry for
I
the
just wanted
interruption.
to show because I think the logging crate there in Pinocchio is so underrated. I hope people are using it because it gives you some good savings. So let's go here. Let me just add the one that does the logging here on the SDK first. I'm just gonna comment this out in case. in case we have questions about this. I'm going to enable this again because we're going to need. I'm going to comment this and let's log. Very simple. I'm just going to log. I'm just going to log the LAN ports of the first account that comes, which is it should be kind of like one soul. So accounts. I'm not gonna. In this case, I'm not gonna. Okay, let's do properly. Let's validate. Let's validate that we have one account. Okay. So let's. I'm gonna validate that I got one account. Okay. Account and then LAN ports. So here. All right. Okay. So I have here. Now we just comment this out. So we don't get that. Okay. So very simple. I'm just checking that I got one account and then logging the LAN ports of the account. So this is a formatted message because I'm formatting here. I use 64. So again, I'm going to build this. And this is a different bench called, I think, log. Okay. So you go there and you see now the program takes 736 CUs. I forgot how much. I think 260 is the parsing of one account. So this is potentially about kind of like 470 CUs is the well, it's 100 for logging. So it's about the formatting of the message is about 370 because it's 100 for logging the message, sort of, kind of like approximately, because there is all the little things that goes there as well. But like it's approximately like 100. So I think formatting the messages is about 370 CUs around that as well. So let's see on the if we go back now on the Pinocchio, we're gonna use the logging, and the other thing is that the log crate in Pinocchio is you don't have to use Pinocchio to use the log. You can use the log in an Anchor program. You can use the log on a native program. It's completely independent of Pinocchio. It just has the label Pinocchio there, but that soon is going to change. So again, I'm going to do the same thing here. I'm just going to comment this out. This I'm going to need. I'm going to copy this. Okay, let's go. I should have copy from the other one. Okay, so I do that, and then here, so the log in Pinocchio uses a macro called log, so it doesn't clash with the same name as the one that is on the SDK. Although it has Pinocchio also has the macro MSG, but then it's going to behave exactly the one as the SDK. And we don't want that because we want to see the difference in the okay, we want to see the difference in CUs. So now it's doing exactly the same thing, getting the first account and logging LAN ports of the account. Let's get rid just this. So I'm going to build the programs again. And I'm going to run the log here. And we see the results. Now we see here there was 455 CUs less than the SDK. Considering and this considering that is 100 is just for the log itself. So this is basically there is the difference in the entry point. The difference in the entry point 260. So if we say 260 is the difference of the entry point, is about 100 and how much of that is going to be 90, 85. sort of thing. Not 95, sorry. No, 85. 85. No, 95. 95. So this 195 CUs less just to format a single U64. If you put an array there, that is going to be significantly different. So if you put, let's say you wanted to, I don't know, for some reason you wanted to put an array, you have to, unfortunately, you have to kind of like put in debug mode, I think. Pretty sure. Yeah. So if you do an array, let's do the array there on the. So literally this you can actually copy just exactly as it is here. The array should be. Oh, we don't need debug here. Okay. So let's do here. So if we do now the SDK and then we do Pinocchio, that should be a much bigger difference. Did it work? Not. I had, okay. Okay, is that I had modified it, the file. That's why. So I do this one and the lock here. Okay. So here you see that now the difference here is way bigger because it's kind of like 266 is just the entry point. So we are talking about 400 the difference now, in comparison to the SDK. So that's another thing that format messages in logs is expensive, using the format macro from Rust. So we kind of redefined one. It's not as powerful, like it doesn't have all the little tricks to format messages, but you get the basic stuff there. Especially if you're just logging LAN ports and things like that, yeah, you're going to be there. And you're going to be saving at least, well, close to 200 CUs per LAN ports, per U64 value that you log. Yeah, that's another way for you to save CUs in your program without massive changes. Literally, you just use a different macro to log things instead of the MSG one. Yeah, so this is the like, obviously there's other things that you can explore, but those are the main points where kind of like CPIs are cheaper with Pinocchio, and the entry point is cheaper with Pinocchio, and other things like getting like the CSVARs, they also like zero copy when you get them. So again, if you're using Bosch in Bean code in your program, the main gain that you can do to your program is switch to zero copy. That is like, it's going to be like half of your CUs are likely to be deserializing and serializing accounts. So if you switch that to zero copy, that's going to be the biggest thing that you're going to save CUs. The second one is switch the entry point.
One question. I know you mentioned earlier that you don't have to use zero copy with Pinocchio. So do you mind just explaining like when should I use zero copy? When should I not? How would I know the difference? Just as someone who's kind of new to learning Pinocchio.
Yeah, I think I'll first put it like, depending on how comfortable you are with Rust. If you are very comfortable with Rust, I would say you can use just zero copy, because I don't think it's going to be a lot of effort to use it, even for small things. You can just use zero copy. If it's small, like if you kind of like, you can even do zero copy on the instruction data if you want, and that saves you not a lot, but it's kind of like about like 10, maybe 20 CUs. Depends on what you're doing, or depends on how comfortable you are. You might as well just do it there. Zero copy, you're definitely gonna need it if you have a large account, because a large account you cannot deserialize, because you're gonna eventually run out of memory, or even use a lot of CUs. But so there are some accounts that you literally cannot deserialize the whole thing. and you're going to have to do a zero copy approach there, or you're going to have to read like chunks at a time. I think I would say first, just like if you're starting, learn how to write a program first. I think that's the first thing. If using Bosch or being code is easier, is quicker for you, then fine. But definitely something when after you wrote your program and you're thinking, okay, how can I make it better? The first thing that I would look is account deserialization. The problem you're using Bosch, like which is what Anchor uses underneath or Bing code, is that you pay 2 penalties for using a Bosch or Bing code. One, when you deserialize, because you have to copy the data into your struct. And then if you modify that struct, you need to copy it back into your account area. So you're paying the penalty twice. And this is why you can get about like 1,000 CUs difference easily when you're working with an account and having to do that twice. So it's the first thing that you can do to, after you go your program working and so on, that you want to make it better. I would say look at the account serialization, how you're going to do it. Then the second, I would say, look at the entry point. Okay, can I use a better entry point here? Which means if you are on the SDK, can you switch to Pinocchio? And after that, then there's all the nitty-gritty stuff that you can do. You can start kind of like looking at how you are kind of like getting your sysvars. Are you using the syscall to get a sysvar? Can you not pass an account to get the sysvar instead? Because if you pass an account and zero copy the data from the sysvar, is way cheaper than calling the sysvar get on the runtime and things like that. But that will be kind of that is optimization that you can do further down the line. I'll say the 2 big ones is zero copy and the entry point.
Okay, awesome. And then another thing that you wanted to chat about, that's just a common misconception with people first reading about Pinocchio, is that you have to write unsafe code. Do you want to talk about that a bit?
Yes. Oh, good point. Thank you for reminding me.
Yep.
I get the impression that people think that when they're writing Pinocchio, you kind of like have to use unsafe code. So one of the principles of Pinocchio is kind of like, there is usually, I want to say always, but I'm not 100%. I'm 99.9% sure. So this is what I'm going to say usually. Usually there is a safe path and an unsafe path. The unsafe path means there are some checks that the safe does that if you guarantee them, you don't have to do them. So then you save CUs. So for instance, one of them, a classical one, is borrowing account. So when you borrow an account, the safe way is to do account, try, borrow data. That is a safe account and a safe way, and you see that it returns a ref to that account. And what it's going to do is going to check whether you can, if you borrow that account before or not, and if it's safe for you to borrow again. But let's say that this program is so simple that is like literally 5 lines. I can see that this account is not borrowed anywhere. So what I can do is say, well, you know what? I'm going to do the borrow data directly and avoid doing the borrow check, which is going to cost you a few CUs. And if you do that, then what you're going to have to do is that you're going to have to put this between an unsafe, because you're going to have to guarantee that you don't have a duplicated account and the account has not been borrowed. So as long as you can guarantee this, then you can do that. But that is, I would say, that is the last step of your optimization. That you shouldn't start with this. Like, it's totally fine to start with count, try, borrow data. This is totally fine to do it. After you sort out your zero copy, your entry point, and so on, then you can look at this. But like starting with this, because if you do an unsafe borrow here, and then you go and use Borscht to deserialize this account, like it makes no sense. Because like whatever you saved here, which was tiny compared to how much we spend on Borscht. So it's kind of like, then you're optimizing the wrong part of your code. So this is why I would say, like, you can totally write a program without any unsafe code using Pinocchio. There is lots of unsafe, like usually they are marked with like unchecked. So they usually, all these unsafe here, you see, they're all with unchecked. There is lots of them there because it's kind of like, well, if you assume those guarantees, you can write even more optimized code. But then again, as I said, this is the last one. And we used it a lot on P-token because on P-token, we were like trying to really shrink every single CUs. So there we were very carefully, you see every use that we do with unsafe has a comment of why that's safe to do it and so on. So that's another good practice to do. If you're using unsafe code, put a comment to say why this is unsafe, and so why this unsafe here is safe. So say, okay, here is and you can put safety, no other active borrows, and the account is not duplicated because I only got one account. So then now this is safe. So although it's marked as an unsafe, this is safe because I'm guaranteed these things. So this is not going to fail, and I save the check. But is something that you need to be careful, and this is why I would say if you're not entirely sure of what that's doing, don't do it. Find out first, and then go back and do it. But I don't think that you have to do it. As I said, there is way more. There are other things that you can do with way more impact in terms of CUs than doing kind of like an unsafe, calling one of the unsafe methods. I don't think there is any unsafe method in Pinocchio that is going to give you hundreds of CUs in savings.
So there's definitely like layers of like how you can optimize the program, and you can just like keep getting more into the weeds with Pinocchio, but there's also ways that you can write Pinocchio programs that are a lot easier if you're newer to just Rust in general and still kind of learning. And I feel like that kind of opens up to our next question. So we have this one question. It was asked earlier, but I wanted to save it till after you are done this demo. But it says, how do we structure a Pinocchio? It's not very opinionated, so there's a lot of different ways to structure programs. And how do you recommend, or how do you recommend people just learn how to structure their own programs?
Ooh, that's very. I think you said it spot on. It's completely unopinionated. Like I sometimes get people asking me, do I have to use zero copy to do account access? Well, you don't have to. Like it's a choice. I think it's I don't know if there is a specific answer here. I can tell you more or less what I tend to do. One thing that I tend to do, but I don't know if it's very popular, I tend to put the implementation of each instruction in a separate file. I prefer having kind of like, so let's say that my program has a create, allocate, and close account or something. I prefer having them separately, kind of having kind of like a folder here, instructions, contact, and then having here a create rs, and then having a allocate, and having a close. So then what it does is my entry point goes, figure out which instruction is calling, and then the processor of the instruction is here. But there are some people like to put everything on the lib.rs. And it's also, I think it varies a little bit of the size of the program, but it's comes down to kind of like the preference of it. The structure of the program is completely kind of like completely flexible to your needs. The way that deserializing instruction data, some people do the kind of like the try from pattern. So sometimes creates an enum, and then from that enum does kind of like a try from, and then kind of like parses automatically kind of like converts that into enum variant, and that tells you what is the instruction and so on. Some other people can go on there, because the other thing you can do here and say, if I take this, so you can do kind of like, and then you can say here data. So I think I tend to use more the destructor pattern when to come to these things, and then do kind of else, and then here return. But again, it's kind of like I think it's kind of invalid instruction data. Yeah. So you could do something like this as well. So basically here is going to be like the first byte is going to end up in discriminator, and then the remainder as I slice is going to end up in data. So kind of like, yeah, it's one way you could do it, and then you do a match on the discriminator, and then you figure out which is your. So if it's 0, then you call process or something, process create, and so on, and then you can pass the data. So yeah, I think that's totally flexible, like in terms of like how you want to structure your program. There is no rules. Pinocchio doesn't enforce anything. As soon as you are his side here, like you can do whatever you want.
Awesome. Cool. So another question that we had was just, where are examples using Pinocchio? I know like one learning platform that's live right now is Blueshift, and Blueshift does have a lot of Pinocchio examples. There's an escrow example there. Also, if you go to Solana developers program examples on GitHub, there is not all of, but a lot of the transfer hook programs in token extensions are using Pinocchio. And yeah, do you have any examples that you know of that are live, Febo?
Example, I think the Blueshift one is a really good resource. Has also a good resource on zero copy there as well. So I really recommend people, if you're kind of like haven't heard about zero copy, or interested in kind of like try it out, I think the Blueshift has a very nice kind of like sort of like guide to go through the concepts, and then kind of like some examples there. There's the guys from the Solana turbine. They're like always putting stuff. I see something always stuff on Twitter. I don't see all of them, like, because I'm not too much on Twitter. But they are. I know that because they're running a program. They use Pinocchio, and they're pushing. So like people keep like creating repos with examples and things like that. So yeah, I don't know if there's an easy way to kind of like keep track of them, but like if you're on Twitter, you check the Solana turbine, and then if you follow them, they usually kind of like retweet when some do that. And yeah, I think those are the kind of like the two main places to find kind of like examples and things like that. There are programs already written with Pinocchio as well that are like, if you go to the token program repo, you have the like P token there. Although that one is kind of can be a little bit hesitant for you to be like looking at that one as your first example, just because that one was really kind of like going max CU savings. So don't think that every program has to be written like that. There is, if you go to the Solana program org, there is the program metadata program, which is the one that uploads IDLs. That one is written in Pinocchio as well, which is probably a little bit more friendly than P-token if it's your first time that you're looking at kind of like a native / Pinocchio program. But I would definitely recommend going through Blue Shift. They have a very nice kind of like, it's not only about zero copy, they go through many things. With Pinocchio, they have some challenges there as well. And then following what the Solana Turbine guys are like pushing out. I see things almost every week. There is something kind of like that comes out there. So
yeah, and also
yeah,
if you're looking for like a more course rather than self-paced, Turbine does have a cohort that works specifically learning Pinocchio. You can just reach out about how to apply and figure that out as well.
And well, I'm going to take the opportunity, since I mentioned them as well, we'll take the opportunity to kind of like give a shout out to both of them, because people from both Blue Shift and Solana Turbine that have been contributing to Pinocchio. As I said, Pinocchio started, but like everybody contributed. So the end state that we are today is kind of is a collective effort, and kind of like KV is one of the, is almost kind of like a unknown contributor almost, because I don't think he has a commit on the repo, but he has done so much contribution. So like definitely like the entry point, this last refactor of the entry point, we were actually literally doing it together, like exchanging Twitter messages over the weekend and kind of like, oh, I saved some CUs here. Oh, I found this other thing. So although he doesn't have the commits there, he deserves a lot of credit. Like Dean and Leo from Blue Shift as well have done tons of contributions there, and sometimes these contributions not directly to the repo, just like they send me a message and so on, and oh, have you thought about this and so on. So they yeah, so it's a collective effort, definitely.
That's awesome. And if anyone here listening to this live stream has come to some of the Q&A live streams that Jonas and Jacob and I have done, one of the common questions we get is just like, why are you interested in blockchain, or like working like as a developer in Web3? And like we always talk about how it's a community and everyone works together and contributes to different projects, even if they're not directly involved. And this is a perfect example. You have people from different companies throughout the Solana ecosystem, and they know that Pinocchio is going to, in the end, help out with their project, so they're going to contribute and to give some insight as it's being built. And also, we've gotten questions on what are things I can contribute to start like learning and showcase my like coding abilities in the ecosystem. So here's a great one, is Pinocchio. You now have an overview of Pinocchio. The code's open source if you want to look through it and start contributing.
Yeah, I think the best way to find what to contribute is actually try to write something, because writing, then you're going to be like, oh, this is not done yet. So then that's your opportunity to do it. And then likely you're going to find things that are already similar to see how you can approach it. And eventually you kind of like end up like finding a specific thing to contribute. But using it is the easiest way to find what needs to happen. Because then if you're trying to do something that is not there, then you got the answer immediately. What should be your contribution?
Yeah, definitely. Also, we have another question coming in. Can you talk about memory layout and padding while defining state accounts?
Okay, so that is yeah, that is completely independent of Pinocchio. Let me just put this parenthesis before we start in that topic. Because sometimes people confuse that you kind of like you have to use zero copy with Pinocchio. So that is completely independent of Pinocchio. This is more like zero copy. So zero copy, there is so if you think about it, there is the way that zero copy works is, imagine that you have this array in memory. So let's imagine kind of like a byte array. like to make it simple, let's say 8 bytes. So you have an array with 8 bytes. Zero copy means is that instead of looking at that as an array of 8 bytes, you're going to be like, this is a U64. Why that works? Because a U64 is represented by 8 bytes. So you can actually say, okay, I'm not going to treat this as an array of 8 bytes. I'm going to treat it as a U64. But that only works if this area in the memory that you're saying that is a U64 matches the way that the VM is going to look at a U64. So it has to have the 8 bytes. If it had 7 bytes and you said this is a U64, then you have a problem. Then what we call undefined behavior, because now you said to the VM, okay, that's a U64, but you don't have a U64 there. When you're talking about structs and even memory in general, you also have the concept of alignment. So on a 64 bits processor, the pointers, so the addresses are aligned, naturally aligned to, the addresses have to be naturally aligned to 8 bytes, multiples of 8 to work. Because that's how the processor is going to go read something from the memory. It's going to read in chunks of 8 bytes. So it's the size of a word. So if you then use something that doesn't naturally align to 8 bytes, then again, you end up in a situation you're going to have undefined behavior, because you're going to have an unaligned read that if you're doing just a pointer cast to say this is a U64, but that address doesn't start from a multiple of 8, then you have a problem. That's the things that you have to avoid. So why we are mentioning all of that? Because when you talk about count data, then when you are laying out your data, you have to think about those things to make sure that all the fields, everything, they are correctly aligned to the expectation of the type. Meaning that, so let's say here I have an account, and I'm going to have here a, let's say a discriminator is a U8. Okay, let me put this on the, so we get the compiler to shout at us when we do something wrong. Okay, so this is an account, and if you look at here, so I'm on VS Code, so I get this hint that VS Code is telling me that this has alignment to 1. So the advantage of this is that it doesn't matter where the pointer for this type exists, because it has a unit of alignment. So any pointer is going to be aligned for this. So I could eventually create a byte here, a slice of bytes, and say just one here. And I could then say, okay, this thing actually is, what was that? I'm gonna have to write something. I'm gonna have to write something valid here. Let's say convert, and I'm gonna return an account, a reference to an account. So here, okay, now I should be happier. Okay. Okay, let's do this a little bit better. Okay. I'm gonna do that. Okay, so that data, so let's say that the data is coming. The data is coming from somewhere else. So here I can actually say that this is in effect an account. Okay. integrate a reference. Okay, so this is a way for you to kind of like a very raw way for you to do kind of like zero copy. Very raw way, because like we are not asserting a lot of things here. So definitely don't do this. I'm just doing this just to exemplify. So here we don't have to care about alignment, because our alignment here is 1. So whatever this data is going to have at least 1, because that's the smallest unit on addresses. So that is fine. So now if in this case I have a U64 here, now I have a requirement that my alignment has to be 8, because a U64 value can only start from an address that is multiple of 8. And in this case, I can't do this anymore like this. I need to actually check first that this data array here is actually aligned to 8, and then I can do the conversion. So that's one point to keep in mind is the alignment. And I mentioned alignment because the alignment is what's going to make padding problematic. So imagine now that I can't think about a good name, so I'm just going to use A. Imagine now that I have 2 fields on my struct. We know that a U8 is alignment 1, because when we had just, even show me here, has alignment 1. The discriminator has an alignment 8 because I use 64. So this is 1 byte. And this is 8 bytes. So you are expecting that this type would have a size of 9. So 9 bytes to represent this type. But that's not true because of padding. So the size of this type is actually 16. Because what is happening here is that, remember that this value can only start from a multiple of 8. So what Rust is doing here, kind of like sort of behind the scenes, is putting a padding here to make sure that that value starts at a multiple of 8. So now I added a new field here, but the size of the struct is still the same, 16. So if you had used Borscht doesn't store the paddings on the account. So if you use Borscht, you're going to end up with, you're going to need 9 bytes to save this type if you use Borscht. Now, if you're using zero copy and you had your layout like this, you're going to need 16 bytes to do it, because there is a padding requirement here. And this is always sort of gonna be there, because even if you move down here, your type is still gonna be kind of like aligned, sort of aligned to 8. So you still theoretically use 16, although you could get away and not use it, because you're never gonna access past that area anyway. So theoretically you'll be okay in using 9. But in memory, Rust is expecting this type to have 16 bytes. So when you're using zero copy, what you need to pay attention is to the alignment of the types. And the alignment of your struct of your account is going to be the alignment, the highest alignment of its fields. So if you have an alignment 8, then the alignment of your type is 8. If you have 16, which has alignment 2, then the alignment of your type is 2. And then in the 4, because then there is a 1 byte padding here. So there is always kind of like, there's 2 things to always keep in mind. Is the alignment of the type determines the alignment of your struct, which then is going to tell you how much padding you're going to need to have. this is the other aspect that doing zero copy kind of like is a little bit more tricky, because you need to have this idea of kind of like alignment. Using a library kind of like ByteMark helps you with that, because ByteMark is going to shout at you if you are not doing it right. if you're not doing, if your type is not aligned, if your fields are not aligned, he's going to shout at you, and then you're going to have to add the paddings to make it aligned. Yeah, I just see KV mentioning pact. Yeah, pact, but pact is a bit tricky as well, because pact, even in the Rust side, then it's tricky to create references to fields that are not aligned and so on. So I think pact with zero copy, it can be, as he put it, it can be a pain to deal. I'll suggest not to use pact, and think about the alignment, and then kind of like fix your alignment of your types properly, and then you should be kind of like, you should be safe. I would say if it's the first time that you're using zero copy and things like that, use a library, sort of like ByteMark is one that is good, because ByteMark is gonna shout at you. So if in ByteMark you do something like I had done before, like this, ByteMark is gonna complain. It's gonna tell you that that is not aligned. And it's gonna sort of force you to put the padding here, so then the alignment is correct. So like that's like, so a ByteMark is a good one to start with, and then you don't have to do these conversions manually. You can use the ByteMark helpers that underneath is going to be doing this anyway, but it's going to be doing all the checks for you, checks that is aligned and so on. And the bytes that you're passing is the correct length and things like that. So again, Blueshift has some tutorial about kind of like touches a little bit about this alignment and padding and so on. And but this is what makes zero copy a little bit is not hard to use. It just required that you have to understand a little bit more. So if it's the first time they're using Rust and writing a program, going kind of like bare bones zero copy is going to be tricky. But you can get there. You can get there with like getting more practice, more experience. You can get there. But my recommendation is that if you don't know exactly what you're doing, don't do it, because that's worse. That's worse. Doing something wrong is worse than having to use a little bit more CUs. When in doubt, just use more CUs, use Porsche and things like that. Yeah.
Awesome.
But yeah, I don't know if I cover everything. I don't know if there's any other.
Yeah, I think you got everything. At least to me.
I would say this is a whole new topic. This part of zero copy, and that's where unsafe comes in a lot as well, because is where you're essentially looking at a byte array and saying, oh, you're actually an account now. So that can't be safe, because the compiler cannot guarantee that. So you sort of have to guarantee that, and this is why the compiler tells you, well, you're gonna have to do this in unsafe, because I can't check that that's true. So you have to guarantee and tell the compiler, yes, I know that is true. And which usually involves you adding some checks there before, in order to kind of like tell the compiler, okay, don't bother, I know what I'm doing. But to reach that stage, I think you need to be comfortable that you know what you're doing. This is why I said, when in doubt, better not to.
Cool. So one other question we had is just, what do you recommend to test Pinocchio programs with?
Ooh, again, I think that's completely subjective. I think I would say, okay, on one hand, I would say if you can avoid using the test Solana program test, that's going to make your tests faster. Because what the Solana program test does is essentially spin out a test validator and so on, and does the whole the whole thing. So this is why they are heavier, they take longer to run and even to compile as well. So there's nothing wrong with that, but if you can avoid, is better. You can write faster tests. On the side of writing faster tests, then if you're doing Rust stuff, you have Mollusk. So Mollusk is not just doing benches. You write the whole tests there as well, have asserts and things like that. And is a very lightweight because essentially has only the VM. So you literally just call your program inside the VM. So it doesn't have all the other parts of the kind of like of the pipeline of processing a transaction. It just goes and just say, okay, I'm going to call this instruction in this program. You can also use the light SVM, and the light SVM has a little bit more of the pipeline because you kind of like pass signers and things like that, and that allows you to do tests that could be slightly different than in Mollusk, or in Mollusk you have to do it slightly different because you don't have that kind of like signer checks and things like that. But I'll say Mollusk and light SVM is lightweight options to use. I'll be my preference to go that way. Solana program test is good, but is going to be heavier. And then if you're doing JS tests, then kind of like I don't know if that is. I think light SVM allows you to. I confess that I'm not too familiar with light SVM in terms of JS tests. So I don't know whether you can use light SVM with JS tests. Mollusk you can't use with JS tests. So Mollusk is a Rust.
Yeah, so light SVM does have a TypeScript that you can use. So
okay,
you have that option.
So that would be a good option. I would say if you can avoid the Solana test validator, just in the sense that if you want something that is a little bit faster, I would. If you can use light SVM as well, it's probably going to be faster to run your tests.
Cool. Well, that was all of the questions we have in the chat. Is there any other topics or things that you wanted to chat about regarding Pinocchio?
Well, one thing that is going to happen in very soon, to be fair, that the next version of Pinocchio, we're going to share some types with the SDK. And the way that we're going to do it is that if we can use a type of the SDK, which has kind of like similar, let's put it the same performance as the one in the Pinocchio, we're going to use that one. If we don't have a type on the SDK that has the same performance as the Pinocchio, we're going to add one. So the end goal is to then have a very easy way for you to have helpers and other kind of like code, especially like sysvars and things like that, shared between the SDK and Pinocchio. So you don't like today, right now, what happens is that if you want to do a CPI, you can't use an existing helper for a program unless it's written with the Pinocchio types, because the types like pub keys and so on, instruction, they are not the same, they're not compatible. So what we want to do is to get to a point where you can write these helpers with a type that is going to work for both the SDK code and Pinocchio code. Which means there are some things that are going to change, and we're going to make it as smoothly as possible. I can't pinpoint, apart from some name changes, I can't pinpoint any other sort of like breaking change that is going to happen. But that is something that I probably going to start working on by the end of this week, like latest beginning of next week. So one change, I don't know if people notice, but there is one change that happens with PubKey. There is a new crate called Solana address. And Solana address, so PubKey now is just an alias to Solana address. And that was the first step to make this integration happen, because now Pinocchio can use the address crate, which is very lightweight compared to the PubKey crate. So that was the first step that we needed to go in, and now we can do all the rest. And that just happened, I think it was like last week or something like that. So I can actually even show you. I don't know if people realize here, but if you go here, pub key says Solana address, because it's just an alias. So this is kind of like the first step. And then we're gonna then continue now. So the pub key in Pinocchio is gonna be that struct Solana address now. We're probably gonna just continue adding the alias to address, but like going forward, I think is the terminology is gonna be address. So yeah, so that's kind of like is coming. Not gonna change a lot, I promise you. So if you're starting to look at Pinocchio right now, there's like you don't have to wait for this, because as I said, the API shouldn't have any changes apart from some name changes. So I think account info might be called account view because there is already an account info in the SDK. So might be called account view. Yeah, I think we're gonna have a type also called instruction view, and things like that. And but yeah, so that's sort of what is coming. But as I said, we're gonna make sure that it's kind of like is smoothly as possible to do it.
Awesome. Cool. Is there anything else you wanted to cover?
No, I think yes, there is a lot to cover. But I think is this I think is a good start. I think my recommendation is so one thing to always keep in mind is that the Pinocchio and the SDK, in terms of structure, are extremely similar. So the way that like is kind of, if you have a native program with SDK, to convert it to use Pinocchio, it shouldn't take you a lot of time to do it. So that's kind of like one thing to keep in mind. The second thing is when looking at optimizing your program, the parts that are unsafe, as I said, is the last thing. Usually, literally look at account access, the serialization. That is what is going to give you the big chunk of savings. So I'll say just start using Pinocchio, but that is not the thing that is going to be kind of like the major thing that you're going to save CUs. If your program deals with accounts, and especially large accounts, the main thing that is going to give you savings is going to be account serialization to use zero copy. So if you're in that scenario, invest in understanding and learning zero copy. The unsafe bit, leave it to last. I promise you, that is the one that saves you kind of like a few CUs, 10, 20. Serialization can save you easily hundreds to thousands CUs, easily. So I think that's my recommendation.
Awesome. Well, thank you for taking the time to chat with us. This is super helpful for everyone who's interested in Pinocchio and understanding like why would I want to learn Pinocchio and how to get started. So yeah, really appreciate you taking the time and would love to chat more in the future because there's always a lot to talk about with building programs. So yeah.
Definitely. Yeah. No, thank you for having me. And again, I just wanted to say thank you to everybody that have contributed. And yeah, just keep contributing.